Let's take a closer look at echo processing in the SITRANS LT500. Quick Start Wizards can ideally set everything up so that 95% of the applications that are out there will provide reliable measurement just running the Quick Start Wizard, and you can walk away. That'll set your TVT type, your algorithms, your filtering, all of that stuff is done through the Quick Start Wizard. And like I said, that'll take care of most applications that are out there. But any applications where fine tuning or adjustments are required, we've got the whole suite of parameters and settings that can be adjusted that are accessible either through help via our tech support guys or directly if you understand them. And I'm not going to go into each one of these parameters specifically and what they do, but we are going to look at the bigger ones and explain how that can help you when you get into trouble or why you might be seeing some issues in your application and how we can fine tune that with echo processing to get you to that reliable measurement. So first and foremost, what is an echo profile? An echo profile is a digitally generated graph of the reflections received by the sensor and processed by the controller of objects in the vessel. So this is anything that's in there. It's the material, it's pumps, it's pipes, it's ladders, it's fill streams, it's ripples, anything that's in there that's going to provide a reflection or an echo back to the sensor. That's what we're going to represent on the echo profile. And before our process intelligence can process a reading or before making any adjustments, ensure that the application provides a material echo. That's the most important thing. Okay, physically check mounting, aiming, where the fill pipes are, your wiring, all your quick start parameters, and double check, is it too dusty or is there a bunch of foam or agitation happening at the time of setup? Are the settings to the factory defaults? Is there external noise? Make sure all of those things are under control before you do any of your fine tuning. Okay, the anatomy of an echo profile, we take our shot. Okay, our echo profile is the blue part of the line here on the graph. Those are the things that we detect out of the application, the material, the obstructions, all of that other stuff. The red line is our TVT, our time varying threshold, and we're going to talk a lot about TVTs, but just to give you an explanation of all the different terms as we go through here. This is our true material echo, and we have our echo selection point there. That's our echo lock window and our confidence marker. Okay, we have our ring down section overlaying on top of the blue line. That's our blanking distance. And we have our noise floor. Okay, and the others, those are indirect echoes, maybe, again, other equipment or things that are in or around the material echo. Those are the things that, we're going to ignore or take away. The TVT is a threshold line that's fixed at a percentage of height. And that's typically 33%. Echoes that are below the TVT are ignored, and echoes that are above the TVT are evaluated by our process intelligence. And the TVT is dynamic. It moves with changes in the profile due to process conditions, and we have all of these other settings around where the TVT can start, its minimum slope and duration. We can get into all of that kind of fine tuning. Confidence value, so all echoes that are crossing the TVT are assigned a confidence value based on our echo processing algorithms, and the higher the value, the greater the probability that that is the correct echo. Confidence threshold is a minimum value for an echo to be recognized as valid, and our margin is the difference between the confidence and the threshold. Okay, so again, ideally we take a shot into a vessel with material and it's a clean shot with no obstructions and we get a nice reflection back from that material. The real situation is that signal is going to see ladders and weld seams and pipes and agitation within the material. So it's not going to be a nice clean echo like you see on the left side of the screen. It's generally going to be something more like what you see on the right. As we go through the steps of creating an echo profile, so first we generate our pulse from the sensor and the signal returns. So that is the return signal. We form the profile. Okay, we apply all of our filtering. We're going to go into that in a lot more detail as well. We establish our TVT. We apply all of our echo algorithms, and we make our selection of what we believe is the true material echo. Okay, the dynamic TVT, so changes in process conditions can directly impact your signal strength, and those could be foam, steam, agitation, dust, a lot of those things that are very typical in an application, and those will affect the signal strength of where our true material echo is. So you could see that echo going up and down like it is in the screen here, and with a fixed threshold, okay, a fixed TVT line, as that signal strength degrades or decreases, it's possible for the unit to lose sight of that material echo and go into an LOE, or loss of echo. Our dynamic TVT adjusts itself with each shot, maintaining a lock on the material level as the signal strength decreases, so we're able to continue to measure reliably even as that signal strength decreases. So that's been a huge advantage of our products over the years, that our TVT is dynamic and it's not fixed. Okay, the echo lock window. So running processes may have dynamic obstructions like an agitator, like you see here, that move in and out of our signal path. Could be a paddle, a rake, a blade. Process intelligence fixes a window around the last selected echo, and then we begin, as we see a new echo emerge where the blade comes into the signal, we begin to expand that window, and if that echo eliminates itself, we reduce that window again. So we're always making sure that we're looking for a change in material, but we want to be confident about that change. So we're not going to jump right to a different echo. We're going to open or widen our gaze and begin evaluating more of the application. And again, depending on your process speed, whether it's slow, medium, or fast, will depend on how quickly this window opens up. But only after 5 consecutive measurements with that new echo and it goes into the window will we jump and change to that new echo as a potentially true material reflection. Okay, we also do multi-shot sampling. That's the number of shots parameter. So we will take any number that's input. Obviously, it will slow your measurement down if you have a larger averaging number. Default out of the box is 5 long shots and 1 short shot. So if we take 5 long shots and we do the average of all of those, that creates our nice clean signal, and that's what we begin to process from there. Okay, if we look at our echo algorithms, we have the ALF setup. So we evaluate all of our echoes based on A, L, and F, area, largest, and first. And scores and confidences are assigned to each echo based on those 3 criteria. And the highest score from the 3 criteria is selected for each echo. The echo with the largest overall score is then selected as the true echo. So ALF for general purpose solids, A for coarse heaped solids, L for liquids in open vessels, F for liquids in closed vessels, AL for fine heaped solids, AF for coarse flat solids, LF for general purpose liquids, TF for no obstructions in liquids, BLF for general purpose liquids or solids, and BL for liquids or solids in open vessels. And finally, BF for liquids in closed vessels where F is producing an unstable reading. So those are all your different options. Again, we set these all up by default, but if you want to change one, that's generally the guideline that we recommend. Again, all of these things are done in the Quick Start Wizard based on your selection and whether you choose your response rate and your material type. If you need to adjust that, lots of different options for you to take a look at. Okay, echo reform is another setting that we have in the device, typically used in solids or also in dome tanks. So again, we create the signal from the sensor, it comes back, we form the profile, we apply filtering, we assign our TVT, and you can see here, because we have a solids application which is somewhat piled into some sort of angle of repose, we're getting kind of a muddled signal back, or maybe multiple different paths of our measurement signal, and it's created this kind of, two peaked profile. So what we want to do so that we don't jump in between those two, after we apply our echo algorithms and select our echo, we don't want them jumping in between because the confidences could be very close, right? So what we want to do is we want to reform that echo so that we avoid this skip off to the side and the signal taking a longer path back up to the sensor. Again, you can see with the trend, without reform, we're jumping back and forth between those two different peaks. And with reform, it's a nice smooth trend line. So we apply the echo reform filter and it creates kind of a melding of those two profiled peaks into one. And then we're able to track that from there just to kind of smooth things out. So echo reform, very valuable again for solids applications, also in applications with dome tanks where we have the sensor mounted right in the center. So that again is another great feature to use with liquids in dome tanks as well as solids. Okay, long shots and short shots. Short shots are close-in measurements, generally less than 1 to 2 meters. It can be user-defined, but in that area, and it uses a narrow pulse width to reduce ringing. Long shots are beyond the short shot range, and that's where we apply all of our different TVT types. The short shot is that squared off brick wall style TVT always. Long shots is where we have the different TVT options that we're going to talk about, and it uses a wider pulse width to provide a stronger return echo in the longer range on the long shots. You can set your device to use only short shots or short and long shots, and that's under the shot type parameter. Again, if you have an application that's really short range, maybe an OCM open channel, you might only want to set it for short shots. Otherwise, using both is very advantageous. So on that long shot type, our default is long smooth 2. It's the latest and greatest in echo processing. It's also used on our radar products. We have short curved for standard short range liquid applications up to 15 meters. Short flat for short range solid applications. Long flat for long range solids. Long smooth front for when the sensor is mounted in the center of the vessel. Long smooth for long range liquid, and slopes for a particular echo, which helps to avoid multiples. So as you can see, I use the same shot for all of these different TVT types, and it gives you an idea of what the TVT type looks like, just as a nice comparison between them all. Okay, so position detect sets the distance based on the geometry of the echo. So as you can see, the little green echo that we have there and the red X is where we're actually going to make our distance selection on the profile. So rising edge percentage is calculated using the echo floor to the echo peak, and it's at a percentage setting, which happens to be 70%. Center is right on the middle of the center of mass of the peak. Rising 2 is calculated using a fixed amount of decibels down from the echo peak, and that's 10 dB. And then we've got a couple of new options in the LT500 for OCM applications only. The OCM, which selects a default wave of the time series from the echo peak, and it's the 4th wave. So as you can see, the actual frequency of the sensor, what we have inlaid in the echo profile, which you'll never see in a profile, but that's all internal to the device. We're using the wave to make our selection. And then OCM2 is a customer selectable wave within the profile. Anywhere up to 0 to 50 will select the specific cycle number from the profile peak. Our digital receiver, our most sophisticated and user-friendly signal processing engine ever. Greater resolution, more detail in the signal, as I mentioned before. I mean, we're actually able to look at time series, less noise, better accuracy, adaptive to process conditions. I mean, we continuously evaluate and adjust for noise levels, noise characteristics, echo strength, echo confidence. We optimize the signal strength and our gain options based on the application, and we have upper and lower threshold settings, which we're able to adjust as well. At the end of the day, just reliable signal processing. That's the name of the game. So additional echo management stuff, again, we can change the short and long shot frequency of the sensor itself in kilohertz, our long and short shot duration and width. We can apply a shot delay if you want to delay in between all of your different shots per measurement point. We can adjust the short shot bias, which evaluates echoes between short and long shot, and if they have the same confidence, it favors the short shot, so we can favor it more or less. We can play with the confidence and the noise peak and the noise average thresholds and raise diagnostics on all of those. We have submergence detection, so if the device, the sensor becomes submerged, we can alarm and raise a diagnostic for that. Have to have a submergence hood on the sensor. We have short and long echo thresholds, which again will help us determine which echoes are evaluated. We can adjust the hover level, which is a percentage of how high the TVT curve will be placed above your profile. We can adjust up and down sampling, which again is the number of consecutive echoes appearing above or below the currently locked on echo that must occur before the measurements are valid and go to the new reading. System sync, where we've got a whole other video that you can look at for sync, system synchronization. So if you're aligning multiple controllers and sensors in different tanks, or if you're aligning multiple controllers and sensors in the same tank, we can do that with the LT500 as well. Scan delay, which is a delay in between your 0.1 and your 0.2 measurement. And again, shot delay before your transducer shots. Stuff that we've already talked about in great length, but just to provide a quick reminder that these echo management functions are available as well. Auto false echo suppression removes obstructions from your application by shaping around them with the TVT. We also have manual TVT shaping as the last point here. Auto sound velocity calibration, auto sensor offset calibration, and auto zero head offset calibration. That last one for open channel flow. So that is just a really good overall high-level summary of all of the echo processing functions that we can do in the LT500. As I showed before, there are a whole suite. The complete library is available and can be fine-tuned and adjusted to your application when needed. For the most part, 95% of the applications out there, that shouldn't be a problem.